Welcome to Mr. Hamilton's Math Bites. In this lesson, we'll look at solving single variable equations. So whenever we're solving single variable equations, there are 4 key steps that are really helpful to keep in mind. You may do things in different orders sometimes, but I find that for most people, these steps are fairly straightforward. The first thing is kill the fraction. Fractions tend to trip people up and lead to the silliest mistakes. So if we can get rid of the fraction, that's a good idea as fast as possible. The next step is the rainbow, and the rainbow is really just the distributive property. It's the property that allows us to get rid of the brackets. And we call that a rainbow because what we're doing is we're actually taking the term in front of the brackets, and we're putting an arrow to each term in the brackets, causing these rainbow shapes to form. Then we're getting all like terms together, so all the terms with the variables and then all the terms without the variables. And then we're isolating the variable. We're getting that variable by itself. So let's look at a couple of examples here as we get into single variable equations. The first one I think is relatively straightforward, and here we have no fractions, so we're going to step straight to the R, which is the rainbow or the distributive property. And so we're going to do negative 3 times z, and then negative 3 times negative 2. And then on the other side of the equation, the other side of the equal sign rather, we have 35 minus 5z. So gather like terms together. What we want to do here is we want to go ahead and take that z and move it to the other side. I'm going to move the z's to the left side. You could also move it to the right. It doesn't really matter. And that's going to cancel it off the right side. And then I'm going to subtract the 6 from the left side. I'm going to do the same thing to the other side. And that's going to cancel the 6's off the left side. So now what I'm left with is negative 3z plus 5z. That gives me a total of 2z. And 35 minus 6, it gives me a total of 29. Well, dividing now by 2, this is our isolating the variable step. 2z divided by 2 is just z. That's why I've divided by 2 to cancel out that 2. And 29 divided by 2 is 14.5. Typically, we want to keep it as this form, as the improper fraction, just because that allows us, if we wanted to check something, to do that more accurately. So we're going to go ahead and check this first one using this answer. So let's check the left side and the right side here. The left side of this equation is negative 3 z minus 2, and the right side of this equation is 5 times 7 minus z. 7 is looking a little bit like a z there too. Alright, so that now when we put in that 29 over 2, that's what we're doing, we're checking this, that's what this is. We're going to be able to solve this and see if we get the same value for the left side and the right side. Well, in order for me to subtract these two terms in the brackets, I need to get a common denominator. And you can clearly see, I hope, that 29 minus 4 is 25. And that just becomes negative 75 over 2. On the right side, we get 5 times 7 minus 29 over 2, which is equal to 5 times, you'll notice I'm simplifying what's in the brackets here because I don't have a variable, so I don't need to use the distributive property first. So 7 is the same as 14 over 2. Now we have a common denominator, so we subtract those, so we get 14 minus 29. That gives me a total of negative 15 over 2. Well, 5 times negative 15 is negative 75. And then that's over 2. So therefore we have the left side equaling the right side. So therefore the y, or z in this case, that's the variable, is equal to 14.5, or 29 over 2. So that's a way we can check it. We don't always have to check it. I might, in fact, only going to check it in this specific case, but we can always go ahead and check if we want to. The reason we keep the left side and right side separate is if we get it wrong and we said they were equal to each other, then all of a sudden we said something's equal that isn't. So we want to make sure we keep them separate and then only at the end conclude that they are equal if we found that to be the case. Okay, so now we're moving on to the second example. And in this case, we have fractions, so we need to kill the fraction. And what we want to do here is if we have fractions, we want to find the lowest common denominator. Well, the lowest common denominator of 6 and 7, I hope by now you realize pretty quickly that's 42. So what I'm going to do is I'm going to multiply both sides of this by 42. Well, the nice thing about this is that 42 and the 7 in the denominator cancel out to give me 6 and 1. And on the other side, that 42 and the 6 in the denominator cancels out to give me 7 and 1. Well, wait a second. Didn't you just go ahead and cross multiply, putting that 6 in front and the 7 in front on the right side? Well, yeah, that's what we're really doing. This is why we can cross multiply. Because by multiplying by the lowest common denominator, it gives us the values that it would do if we were to cross multiply. So we can simplify this. It just becomes 6 times 5 times x minus 3. And that's equal to 7 times negative 2 times x plus 4. Now, be careful. 6 times 5 is 30, but don't also multiply the 6 times x minus 3. Otherwise, you'd be multiplying by 6 twice. So we're just multiplying by that 5, right? This isn't an application of the distributive property because this is 6 times 5 times x minus 3. We only use the distributive property when we have values separated by addition or subtraction. So we're going to get 30 times x minus 3. And we're going to get negative 14 times x plus 4. Expanding this out now using the distributive property, using that rainbow rule, we get the following. 30x minus 90 and negative 14x minus 56. So now we gather like terms together. I'm going to add 14x to both sides. Again, it doesn't matter what side you bring your x's to. Generally, I like to bring it to the left, but I won't always do that. That's going to cancel out the negative 14 from the right side. And then I'm going to add 90 to the left side. That's going to cancel out the 90 there. And then I'm going to do the same thing to the other side. So it's going to give me 44x, and then negative 56 plus 90 gives me a total of 34. Now I want to isolate the variable. So I'm going to divide by the term in front of the x, which is 44. And so I get x is equal to 34 over 44. Two final examples to just get us comfortable with this, in particular with this idea of using cry and killing the fractions. This first one here is 5y over 6 minus 1/10 equals 4 over 5y. Well, the first thing I want us to recognize is that that y is not necessarily associated with that fraction in any way. So we can just take that y outside or to the side of the fraction. And what I really need to do here to kill the fraction is I need the lowest common denominator of 6, 10, and 5. Well, the lowest common denominator here is 30. So what I can do is I'm going to multiply every term by 30. Maybe it would help you if I thought about multiplying the whole equation by 30 first. Let me write this correctly. 1 over 10. And then I'm multiplying the other side by 30 as well. So what I really get here is I get 30 times 5 over 6, y, and 30 times 1 over 10, and 30 times 4 over 5y. Now you may say, well, I get this. It seems like overkill for the steps, and that's absolutely correct. Some of these steps aren't necessary, but I want to show you clearly how this works. The 30 and the 6 cancel out rather nicely to give me a 5 and a 1. This 30 and 10 cancel out nicely to give me a 1 and a 3. And this 30 and this 5 cancel out nicely to give me a 1 and a 6. So 5 times 5 just gives me 25y. 3 times 1 gives me negative 3. And then 6 times 4 gives me 24y. So now I want to collect like terms. This is one of those cases where I'm actually going to bring the y to the right side because I already have the non-y terms on the left side. So I get the 25y canceling on the left side, which just leaves me negative 3. And then I have negative 1y on the right side. Divide both sides by negative 1, and we find that y equals 3. And last but not least, we have the case of fractions and non-fractions in an equation. Same thing. Again, the lowest common denominator is, in this case, 12. So I'm going to multiply both sides of this equation by 12. Twelve times 5 is 60. The reason I'm using the distributive property here on the right side is because these two terms are added together, or actually here subtracted, which we could think about it really is adding a negative. And so 12 times 5 is 60, and 12 times 1/4, well, that's 12 times 1 divided by 4, that's 3. And we can do that step all at once. Now the next one, I'm going to go ahead and I'm going to actually just multiply the 12 times the 3 to begin. So I'm going to write this out as 36 times negative 2 plus 7 over 3x. So let's continue on with killing a fraction here before we get anything going from there. You'll notice here we've actually used the rainbow rule before we've killed the fraction. So the first two steps, the k and the r, can be interchanged. So the 36 times the negative 2 and the 36 times the 7 over 3. So we get negative 72, and that's added to 36 over 7. Well, let's just think about that for a second. That's 36 over 3. And so 36 over 3 is the same as 12 over 1. So what I'm going to get here is 12 times 7, which is going to give me a total of 84. And that's just over 1. So I don't even need to write the denominator anymore because I've canceled out that fraction. I've killed that fraction. So it's 84x. So now to gather the like terms together, I'm going to add the 3x. And again, I'm going to bring the x's to the right side. You could have brought it to the left side. And I'm going to add the 72. So what I'm doing here is I'm getting rid of the 72's off the right side. I'm getting rid of the x terms off the left side. And I'm going to get 132 is equal to 85x. Now I divide by the term in front of the x. This is isolating the variable. And I get x is 132 over 85. That is listed as an improper fraction. And again, if we wanted to, we could write that as a mixed fraction. And a mixed fraction is just where we take that, we get 1 in this case, and then we're left over with 15 and 32, which is 47. And that would be it as a mixed fraction. Again, either one of those are acceptable, but if we're trying to graph something, sometimes the mixed fraction is easier to see on the grid.